explore the dark web, we have come across cases where children. So how safe is it? That's first question. And second is regarding the forensic that you had been talking about, because I feel that the geographical boundaries between different countries, there is a lot of restriction when we talk about the data being taken cross-border exchange of data, not exactly exchange of data, but stealing of data. And also for does the association or the forensic experts, for every cross-border data which has been stolen, they have to take the permission from the government? I mean, is it as per the rule, is it supposed to be doing that every time? That means are these forensic experts, they are restricted and limited with respect to doing the investigation for every investigation they are going through? So that's my question, sir.
First question is related to the Tor browser. Many countries, yes, they have the dark net web is illegal in many countries. Okay, so many countries, what they follow, whatever you can access through your surface web and deep web, that is legal, and the anything which are that is illegal. Okay, now second thing, what is when children are using it? Now, even if you go through the regulations of some of the advanced countries like USA, they have a rule wherein they can investigate if somebody has used a Tor browser to access the darknet. So these even advanced countries, they have a rule and they permit their FBI agencies like FBI to investigate. Second thing, if children are using the Tor browser, what I recommend, anybody has ever gone into a dark net or accessed it, so you will find a lot of illegal activities. It takes place in the dark net. A lot of things to offer, and lot of material which is legally not accepted. For example, kind of crimes, drugs, human trafficking, and child abuse related. So you will find in plenty in dark web. So what I recommend that that it should not be accessed by the children. And in our country, we have a very strict regulation, and most of the even in surface web, what to access and what not to access. Even the firewalls are blocking the access of some of the websites. So you can understand that countries which are not giving access to the illegal website, they don't promote they don't promote the use of or they don't promote use of such resources in any way. And this is the stand of the most of the countries, and that's why the darknet, accessing darknet in most of the countries is illegal. Yeah. And second question is related to cross-border data that may be stolen. So now we need a legal framework. For example, if some country, they have a hostile relationship with another country, so how they would be able to get the data or the information in case of any data breach, and if the servers are there in the hostile country. So it means there is a requirement of a legal framework, and that legal framework should facilitate a cooperation between these two countries. So if the country demands something for digital or legal investigation, that country should be in a position to give. But unfortunately, there's a lack of cooperative frameworks or a cooperation among many countries, because they follow their own regulations, they follow their own policies, they follow their law. So there's a requirement has been felt by the international community to discuss and come with one internationally acceptable uniform on especially on issues wherein cross-border or cross-geographical data transmission or exchange of data is there. And let me tell you, some countries, they have done a wonderful job, like Japan and all, and even Canada. So they have their some the policies where they have refined, or guidelines they have refined, wherein they have a very good mechanism to monitor the data, or how it is coming related to the these issues which crops up, especially when there is any dispute. So countries also need to have some framework wherein they should look into their interest, that if some data is going to some geographical boundary which is beyond their jurisdiction, then how to handle that, and in case if there is any breach, then what should be the procedure it should be adopted. So but then this is a thing which uh, needs more deliberate effort and cooperation from the decision makers, even from government, and unified approach also. So a lot of work to be done in this regard, or in this direction.
So, sir, is there any possibility that a country, I'm not talking about our country, and in general talking about, is there a possibility that these countries may be using, hackers to, in case they are assuming that, how legal is it to have the hackers to take the data back from, from, in case some kind of steering has been done or some kind of investigation has been required? So how legal is it? Is it legal where the countries can hire the hackers to take the data back from the place where it has been stolen, like?
Hacking, as per our legal framework, whatever legal framework we have, it is illegal. And for example, if some international hacker is involved, okay, and if he has hacked into the system in India, then also there is a provision to, legal provision to address this issue. But then how forthcoming that country will be there to cooperate, it all depends between the cooperation these two countries have. Okay,
Thank you,
if
sir.
they don't have any mutual agreement. Okay. Anybody else? Anybody else? Okay, no questions. So shall I close the session now?
Okay, sir.
Okay, thank you, madam. Thank you.
Okay, sir. So
No?
I would like to thank you. So, dear participants, actually our inaugural session got delayed. So we have lunch now, lunch break now. We'll take 45 minutes break, and then we will continue our next session that I have already shared with all of you in detailed schedule. So let's have a lunch break, and then we'll continue.
Hello. Very good afternoon to all of you. I am audible?
Yes, ma'am, you're audible. Good afternoon, ma'am.
Okay. So this is the first session after the lunch break.
Your voice is not coming, ma'am. Ma'am, are you listening me? We are unable to hear you, ma'am.
I think there is some network problem her end, so I'll just call her. So the next topic is on different types of storage devices and file systems. And Prabha Kumari, she is one of the digital forensic expert. She has worked last 2 years on an project related to an ICFS for capacity building in law enforcement agencies between police and judiciary people. And she has also worked in the similar kind of project for the Uttarakhand police. So she will take the session on different types of these storage devices and file systems.
Ma'am, is there any problem? Because session is not started yet now.
No, she is just joining again because there was some problem while sharing the PPT. So she is just rejoining.
Please don't worry. Session will be continue.
Okay, ma'am, we are waiting.
Okay, sir. Okay, I am audible.
Yes, ma'am.
Okay, so we can now start the sessions. Different type of storage device and file systems. Why we are learning these things? Because it's quite important. Any kind of informations we are storing in form of somewhere, like in hard disk, some remote locations, so that further we can get some data. And we are aware that we are using different kind of operating system, and different kind of operating system has different kind of file systems. in forensic point of view, it is quite important we have to learn the type of storage device, what are their structure, how the data is captured over there, how they are stored, and in file system at which location, how the data are managed. And at the time of gathering of evidence and analysis, it is quite important if you are quite aware of which kind of operating system it is, how it is, files are organized, in which location we can get the data, how the data recovery can be done in the particular operating system. Because in different operating system has different places where data can be stored, and recovery point of view is also quite different. If you are talking about the window point of view, it may be different. Or if you are talking about Linux operating systems, so different operating system have different structure, their different mechanism can be used, different tools can be used. That's why first, before starting this forensics, which will be maybe next session and tomorrow sessions, first we have to understand the brief overview of storage device and file systems. So in file systems, in storage device, we will discuss most commonly used device, and file systems we will discuss about a different kind of file system used in different operating systems, how they are organized, where their data is stored, what happens when data is deleted. All these things we will discuss in this session. Now the question is, why so many different storage devices? Because IT and computer science is one of the area which is quite changing day by day. New technologies are coming up, large volume of data we are producing day by day, and higher demand and need of storage capacity is also coming into the picture. So there is need, there is a requirement to develop new technology, so you can use the storage device to generally fulfill our day-to-day need. Because every day now everything is now in digital form. So we require large volume of data to be stored in some places. Now we'll discuss about the type of storage facilities. The storage of data informations generally either done in temporary basis or for prolonged time period until the user wishes to erase the data. So generally we are quite aware that there is two type of storage facility, that is either volatile storage or non-volatile storage. If we are talking about the volatile storage, generally we refer to residing memory in the physical memory, that is RAM of the computer systems or network data. So those data which will be not persistent after the power off. And on the other hand, if we are talking about a non-volatile storage, it is generally defined as secondary memory of the computer system, which is retained even after the power supply is detached from the system. So basically we will discuss about the type of storage facility, which data will be stored long time. Like we will mostly will discuss in this session non-volatile storage. So first thing we will discuss about hard drives or magnetic hard drives, because in from earlier days we are using magnetic storage, but nowadays we are using SSD. I think a lot of places and within few years we will maybe move towards the SSD, but nowadays we are using hard drive, magnetic hard drives. It is most common type of storage used with our computer systems, and it is extremely large, and data can be arranged in an orderly manner, and every platter of the drives concentric circular path, that is known as tracks. And after the formation of track, each tracks is further decomposed into a smaller area, which are called sectors. Now the question is, how magnetic storage actually work? Because in Data is stored in magnetic fields in hard disk, and magnetic fields are organized into tiny magnetized regions, where each region represents a bit. And magnetic disk medium contains iron particles which can be polarized given a magnetic charge in one of the two directions. So each particle represents either 1 or 0, 1 for on, 0 for off. And each bit of data that CPU can recognize. And disk drive generally uses read-write head containing electromagnet to create magnetic changes on the medium. Now you can see in the pictures how magnetic storage actually work. So this is how if the medium rotates, the head write the data on the disk. So this is the descriptions, moving plateaus in each disk and the magnetic fields 0 and 1. The data will be written in the disk. Now another storage device which is nowadays we are generally using in system as well as in our laptops, that is solid state drives. So in SSD, a storage medium that is similar to hard disk, that is we are using, and it is without power. It has ability to maintain store data in a permanent state, and it has highly reliable, noiseless operations, lower power consumption, and faster access time because it has no moving parts like hard drives. And also it is lightweight and quite durable, but it is quite expensive also. That's why still we are using a magnetic storage device. Now we're talking about the another storage kind of devices, flash memory devices. Like our USB drives, it is also sometimes we refer to thumb drives, pen drive, flash stick, flash drive, or even memory stick. So it has data storing device which consists of flash memory integrated with USB interface. It has much smaller in size as compared to hard disk or optical disk, and they are smaller, faster, and much durable and reliable because of the absence of any kind of loose or moving parts. Flash drive, like USB flash drive, is a portable storage device and used for data storage, that is also known as pen drive, thumb drives. Earlier we have discussed, and it has connected via USB port. So you can see in the diagram the component of USB thumb drives. So there is a USB connectors, then we have USB NAND flash, and then we have data storage facility. It is quite lightweight. It is based on the chip, so it is lightweight, easy to capture, and we are very frequently using. Everybody I think using. Another is flash drive is compact flash. It is type of flash memory that is commonly found in digital camera, PDAs, and other portable device. It is a 50-pin connection storage device that is capable of storing data generally range to 2 MB to 128 GB. Optical disk. Nowadays, day by day, we are less using optical disk because we have lot of flash drives facilities already available. But also some places we are using CD or DVD. That's why we discuss this storage device. So this is optical disk in a circular shape. I think everybody has seen it. It has light-based technology for storing, reading and writing data on the disk. But modern days we are using laser beam for reading and writing of data. It is also a secondary storage device, non-volatile in nature, and generally we are using the digital video disc, that DVD or compact disc. Let's discuss about the component of CD or DVD. So there is a circular track, and the track is further divided into sectors. And now what is sector? Sector is basically data, smallest data unit. In sizes, basically one sector 512 bytes generally. And there is another terms you can see here in the slide is cluster. Now what is cluster? If you are further, you can also discuss in the disk forensic also. I am also discussing over here. Cluster is basically collections of more than one sectors. And what is the use of cluster? Cluster is basically used, suppose you are creating any file, whether your Word documents and something, presentation, PDF, whatever you are creating in the systems, for holding any files, we require cluster. Cluster is basically combination of more sectors. So for any file we are creating, at least one cluster is required. So this is the logical unit. You can also check in your operating system if you are using Windows system. Cluster is what is the size of allocation unit, you can also see. Basically it's vary system to systems. So how many sectors can be become, what is the size of your allocation unit? If you want to check in the Windows systems, you can run check this command and you will get the, generally by default 4096 is selected, that is 8 sectors is equal to 1 cluster. So whenever you are creating a file, minimum 1 cluster is required. And in this forensic you will learn details about this. Now we will also discuss about the storage area network. So storage area network is basically dedicated independent high-speed network interconnect and delivers shared pool of storage device to multiple servers. Suppose in our office, we want to use, we have a large volume of large capacity hard disk, and we want to share with the 2 and 4 systems together. So in that case, we can create the shared pools, and we can create the multiple can connect server as well. So storage device, and each server can share the storage that attached with that particular storage systems. So it is basically assembled with cabling, boost bus adapters, and its multiple hard disk is organized together, and we can just access whatever requirement we required, we can get that from there. In next slide, we can see the typical representation of storage area networks. In this example, you can see here, there is these systems are all connected with there is application server, mail server, then we have, these are all the systems are connected together, and then through switches, and we can access different operating systems with different nodes can access this services. Now we will also, another term is remote storage. Remote storage is also known as virtual storage systems. So virtual storage is type of storage facility where data is stored without using any physical storage medium, like hard disk or USB drives. And disk space of the computer, there is no need to expand it for storing the data. Cloud is also a type of remote storage facility where one can store enormous amount of data of millions users. One of the major advantages of this remote storage is the user only needs internet connection to access his or her files, nothing else. So easily we can access from anywhere, modify and save their data from the remote storage. because this time remote storage is quite popular also, and the server machines and all. We have no need to directly work on our physical systems. It will be stored in our remote locations. We can access whatever assigned authentications, and we can get the data, we can work on that, and we can submit our data to the remote locations. But the problem here is accessing required some kind of authentications, some security issues is also there if we are accessing from a different location. So there is some rule regulations would be there. Now we can talking about another kind of storage is cloud. So cloud system is also known as that involves storage and delivery of data, application and services over the internet. And this type of remote storage services where resources and data are somewhere else at remote location or virtual hard disk, and it can be accessed only through the network. In cloud storage system is also we can refer sometimes indicate the user to store space resources which they are paying for it, because in a cloud model like storage and answer, so you have that and they will be managing data and other things, and at the forensic perspective, gathering the cloud data, analyzing it, it's quite difficult because the particular cloud locations, multiple users and enterprise data is stored. So first thing is they will authorize by the service provider. Then they can get the access, and then they can getting the data and all is quite difficult. It's not as easy as goes like in our organizations, we generally sees the data and we can get the data easily. But in case of cloud storage, there is some legal issue, some privacy issue, lot of issues are there. That's why cloud forensic is another challenging area. Now we can discuss about disk. So one thing generally before using our disk, formatting is a term. Everybody is using it. So if you are using magnetic disk, in that case, what we can do? So first it will be formatted disk to determine how data will be stored. So during the formatting, the disk create circular tracks around the disk surface and divided into the sectors. And generally OS organize this as a cluster and then tracks each file's location according to the cluster it occupies. There is a two terms generally we have heard about: formatting, normal format and quick format. So what is the difference between these two? Why there is a quick format? Why there is a normal formatting? Because in case of quick format, just formatting the process, but it does not check for the bad sectors, which is quite important. If there are any bad sectors, that person's data cannot be accessed, and we cannot write data over there, and we cannot access data from there. And full format generally done additional steps to check the hard drives for any bad sectors exist, and it will check to make the full format. That way it's take more longer time than quick format. So it is full format is a good option. If there is any issue exist in the drive, we will able to know at the time of full format. So now there is a brief introductions of storage device. Now we will discuss about the file systems. Why file systems is important? File system is nothing but a method of storing data and organizing computer files, and the data make contains it easy to find the access them. Suppose if there is no file system present in the system, what will be happen? If you are storing any kind of data, it will be may store any locations. How you will able to know? Because there is earlier we have few MB disk like floppy disk we are using. I think as 25 or 30 years back. Generally external storage is floppy disk and something like that. Few MBs of data stored. In that case, we are able to find out how many data is there. But now the million trillions of data is floating around in the systems. And if there is no file systems, then how we will able to know which locations data saving and retrieving is quite difficult. That's why we need some kind of file systems. So file system tracks the free space as well as a location for each file. And if free space is unallocated space, it either empty or file that previously occupied location has been deleted. So unallocated space doesn't mean that this is complete empty. There is no data is available. It might be possible some file is deleted, but data is still over there. Now one thing, so if you are storing any files, what we required? We required some unallocated space. So first we will discuss about what is allocated and unallocated space. So file system generally categorize all the space in hard drives in generally two ways. Either it is allocated or unallocated. So through window interface, we are unable to, if any data is deleted, but that space is marked as unallocated space, but we can't see the data. So it will be available for writing the new files. And allocated space is where some data which is visible to us, we are able to see that data that is available and whatever file is stored. So whenever we are creating a new files, in that case, our operating system will be search the locations where we can unallocated space where we can save this particular file, which locations we can allocate it to this particular file. So it is quite important that not used does not always means empty. If there is space in unallocated, it doesn't mean that it will be totally blank. It is unallocated means the file is deleted and a space is marked as unallocated. So that in that place we can write some new files. It is available for the another file to write that file. Now another things which is quite important, slack space. Slack space is what? File system generally categorize the space on hard drive in either two ways, unallocated and generally slack space is coming to pictures. I think this is repetition of slide. I'm sorry. Slack space is basically whenever you are creating a file. For example, one allocation unit is 4096 byte, right? In that case, if you are creating a file which is only 3 KB, 3 MB and something like that, and the space is suppose 3500, but one cluster size is 4096. So whenever you are saving that file, at least one cluster is allocated to the file. In that case, rest of the space which is not used is termed as slack space. Because in cluster, we are not using the fully utilize the particular cluster. And rest of the space, whatever data we are storing, suppose capacity is 4096 and we are using only 4000. So 96 KB is basically the slack space. So again, we are talking about the sector and cluster because cluster is basically allocation unit. So whenever we are creating any files, we require one allocation, at least one allocation unit. So generally we use 512 byte as a sectors and one sectors, only 4 KB cluster, 8 sectors, maybe 8 KB cluster. So it's depend. And cluster is basically smallest logical amount of disk space that can be allocated to hold a file. Storing a small file on file system, which will be large cluster, will be wastage of space, and such wasted disk space is called slack space. So slack space at the time of forensic analysis, why I am discussing over here, slack space is also quite important. For example, suppose earlier we have created a file which is allocated with 3 cluster, and then we deleted that file, and the next time another file is created which is hold only 1 cluster and 2 the earlier clusters where data is still there. So at the time of forensic analysis, partial recovery of that files is also possible. So at the time of disk forensic analysis, slack space analysis is also important. So whatever cluster size should be at the time of installations of operating system, we have to make optimize, so that if we are storing smallest file, in that case wastage of space will be not there. Now I will discuss about file system types. File system is a set of data structure like tables to manage all the files. So in this session, we will discuss about the disk file system like FAT, file allocation table, different versions, FAT12, FAT16, FAT32, then NTFS, then extended file systems 2, 3 and 4. Now for the Linux systems, then we have Apple file system, HFS, and Android. So these are the few file system we will discuss further. So first we will discuss about the FAT file systems. I can understand that nowadays we are not using the FAT file systems because but first we have to discuss about the file system. So this is the very basic file system. It is used at the time of when the DOS version is coming up. So at the earlier time DOS version we using FAT12, then come up FAT16, and then Windows systems coming up final version of FAT32. FAT32 was using in Windows 95 and then other Windows operating systems at that time. And nowadays we are using NTFS file systems. So first we will discuss about FAT, then we will discuss about the NTFS file system. So in types of FAT, we'll discuss about maximum capacity. FAT, if we are talking about the FAT12 file systems, is 2 MB. And generally that time a floppy disk where it is used. Then another there is a grade come up, FAT16. So it maximum capacity is 2 GB. And mainly this is used in DOS. And then FAT32 maximum capacity is 2 TB, and generally it is used for Windows 9X, like 95, 98, something like that. Now let us see the structure of FAT32. So we have boot record, then we have copy of boot record, then there are 2 copy of FAT, then some reserve sectors is also there, which is in yellow color. Reserve sectors are there for the future use. And user data. At the right hand side you can see the user data. So this is basically where this place actual data is stored. And what we can see what the boot record do. Its area is basically the first sector of the volume, and first sector basically it is simply the program code for booting the Windows operating system. So there is several parameters you can see in the previous slide. And reserve area basically for future use, FAT1 and FAT2. So these are the basically if where mapping of the cluster is there. And if in case of one FAT is damaged, so another FAT will be work, and our for the safe file systems, so at least minimum 2 copy of FATs would be required. And data area where files and directories are there, we can store in this area whatever informations we are reading or writing by the logical unit cluster basis. So other things are generally stored in that area. So whatever we are creating, it will be stored over there. Whatever deleting, it will be there. Only entry in the FAT will be changed. Then we have extended FAT come up. Generally, it was introduced in 2006 and was added to older version of Windows, updates to XP and Vista operating system. So generally, it is that time most updated file systems were in OS, and this is compatible with the flash drive also, and it is extended file allocation table and large limits of files, big partition sizes. It optimizes expat for the flash drives. So nowadays some flash drives we are using standard FAT also. Then come up NTFS file systems, that is new technology file systems. So then it was introduced in 1993 for Windows NT, and it was used in earlier version like XP, NT, and it includes journaling, encryptions, and disk quota, reparse point. These things are included in NTFS, because if you are using FAT file system, it was not encrypted. So there is a security problem, and if you are using, if NTFS is used, it is encrypted, it is more secure. And nowadays we are using in all the operating system NTFS file system if you are using Windows operating system. So now sometimes we are also called NTFS file analysis or NTFS forensics. So why we want to learning this? To understand its format and inner working. Because whatever file recovery we want to learn for the deleted or lost data. So first we have to understand how it is, at which places the data is basically stored, what are the metadata, and forensically useful artifacts like existence of hidden timestamps, logs, deleted and leftover metadata, and these are the artifacts we can get from the NTFS forensics. If you are able to see it, hidden files and folders of any NTFS systems, you can see this, all these attributes of NTFS. So everything is a file in core of the systems, and these are always hidden from the user point of view. If you want to see these attributes of NTFS, you can just check out the hidden data. So hidden data in Windows system, you were able to see this NTFS internal, some hidden internal of NTFS. Like earlier we have seen case of FAT file systems, there is file allocation table. That is FAT, that is file allocation table. In case of NTFS, we have master file table. And these are some attributes of the NTFS, where it is NTFF mirror, that is backup of 4 records of first 4 record of MFT. Then we have log file, that transaction log files of the files where you can get that informations, volume related informations. Then we have attribute, names and numbers. Then we have bitmap, which is showing the which cluster of volume are in used, and boot code during the bootstrap, and bad cluster. So mapping of the bad cluster, if any bad cluster is exist, informations will be there. And there is access control list and secure attributes over there. and knows all the lower and uppercase character mapping and optional extended list. So these are the hidden files available in NTFS file systems. Now we can see the physical layout of the NTFS volume. So the boot, this is the 0th sectors of any hard disk, where all the booting related information will be stored. So if sometimes we heard about that we are unable to boot the systems, so maybe some head is damaged and something like that. So if 0th sectors is damaged, in that case booting will be not possible. Data is still there, but we are unable to boot the Windows normally. And after this internal files, after boot sectors, we have some internal files information is also available in the 0th sectors. So generally it is starting of first cluster and second cluster, boot informations, and then we have this all hidden files, MFT and bitmap, all information is available. So generally whatever informations we are storing, we require some kind of free cluster. So you can see some physical layout, the blue colors marked is allocated cluster and free cluster are in gray color. So whenever we are creating a new files, it will be stored in the free cluster. And what the master file table will contain, it consists of 10254 byte records, and it has entry of every file and folder including itself, and records can be identified by header file. So which kind of, because in whenever we are talking about different kind of files, so how we can identify? It might be possible some users try to hide the informations and they change the file extension. File extension can be changed, but in that case their header information cannot be changed. So whenever we are analyzing the file header, we are able to know whether this file is sometimes, suppose for example, if you are have an image file and we store as a Word, so whenever we try to open in the Word, it will be not open. And when we are analyzing using the forensic tool, if you try to analyze the header of the file, we are able to know this is not the Word file, rather than it is image file. So in that case, we can open that files in image. So in forensic point of view, file header and its attribute, and also metadata is stored in attributes. So all the informations over there, if any transactions is done, any attributes, when it is created, when it is last modified, this kind of information we can also get by analyzing the MFT. So forensic tool use read the MFT of that particular disk if you are using Windows operating system. So in that case, we can get the informations. Now we can understand how the file is actually stored. Suppose for example, I'm creating a new file like hello.txt, and there is a data attributes, because whatever information is stored in data area. So there is a file length is suppose I required 3 cluster. So in that case, what we can do, we can see the 3 consecutive, either we can store in the 3 consecutive cluster, or you can store in somewhere else. So 52 3 lengths, and it is stored. If it is length is 2, we can store this 2 sectors is required. So these informations we can store in the unallocated space. First we identify the operating system unallocated space, and file is stored. And their entry is also done in the master file table. We can see another example, like file system keep track of NTFS or FAT32. Suppose we have 2 and 3 files over there. So bio.txt required 3 and 4. So these two cluster is consecutive cluster. We store one file. Then we have second file is a store. We require 3 cluster, but it is stored in 7, 8, and 10 because the 9 cluster is allocated to another file. So it is not free. So whenever we creating a new files, it is not stored. If it is no consecutive sectors cluster is available, in that case it will be look for another free cluster, and that will be allocated to that particular file, and this informations will be enter in the master file table. So next time we are going to access that files, it will be based upon the entry, the file will be retrieved. So all the index informations will be there. Suppose for example, if you are deleting like file bio.is3 and 4, so it will be marked by the operating system. This is our unallocated space, and we can create that files, but data is still there. Only entries, some tilde space is there. You practically you can also see here over there, and that space data is still there. So whenever we are trying to use some forensic tool, we can recover data. Using the Windows interface, we are able to, it is not visible to user, but data can be recovered from that place. So actually data is not actually deleted. So this is what, when a file or folder is deleted, actually the file content is not deleted. In directory entry, the first character of short name is replaced with a special character. So it is marked as a deleted file, and that file cluster can be unallocated space. So if no new data is stored in those cluster, that data sit over there for years. So if you are write any new data over that place, in that case, the data will be overwritten and it cannot be retrieved. Suppose for example, how data recovery can be done. We have old examples like FAT60 partitions per cluster has 2 sectors, and sector size is 512 bytes, and one file is one txt file. Its size is 1040. So free cluster we have 200 to 400. So starting cluster is this 200 cluster will be, and it required 2 cluster because the file size is 1040. So this is the FAT entry, timestamp, when it is date of creation, date of modification, and all over there. Second step, we can delete that file. So because this is the FAT, if you are delete the file, everything will be generally marked as 000 because 200 and 201 we require because the file size is 1040, but our cluster size is more than that. So these are some slack space you can see in 201, that is second cluster. There is some slack space. So their FAT entry is marked as deleted, but data area that is already there. So whenever we see in the FAT tables, we can get that informations. So we can go to the entry file FAT tables entry and the starting cluster number and size of the file. So what is the starting cluster number and size of the file, and how many clusters is occupied by the particular file, and we go to the data area and we can read the data from there. So basically in this logic, our best forensics tool will be working on that. So whenever we are deleting any kind of data, then data area, the information actually not deleted, only entry in the either in master file table or file table, it is marked as deleted, and still we can get the data till it is not overwritten. Now we will discuss about the Unix file systems. So almost everything is a file in Unix operating system. As file has property like which kind of file, access permissions, like read, write, and execute permission. I think a lot of people are using nowadays Linux operating system or Unix operating systems. So file type with different kind of permissions. So you can either change the permissions with different commands you can use in graphical interface. If you are Linux, we are using either we can using the commands, and we can also use a graphical interface. So there is a link count, ownership, who is the owner of the file, what are the group membership, like particular users. If you are using this particular systems, so there is some permission is assigned to the particular group. So this files is basically associated with the particular group, and date and time of last modifications, and the file name. Similar to the NTFS file system as well. So this is also there. In Linux operating, we are using extended file systems. So that is AICTE or extended file system. So it is traditional file system which is designed to use by the Linux kernel, and its original version was succeeded by AICTE2, and I've seen in 1983, and now AICTE family consists of AICTE2, AICTE3, and AICTE4 respectively. One of the benefit of this, especially AICTE3, and that it is has feature of journalings. So in this case, it allows to keeping track of all the changes in the files. Suppose, for example, if there is any like power failure and something, we are creating some files, some changes are recorded in journal, which is a log, and it can be data recovery is easy. Sometimes we are open files in the recovery mode. So we can see the Unix file systems structure as well. So yeah, owners can change many of these data modification time. So it consists of 4 blocks, like boot block, super block, inodes, and data blocks. In case of NTFS file systems, or either you have we are talking about earlier in FAT file systems, the 0s sectors is in case in Unix everything is block. These are similar things, but 0th sectors or 0th block is basically used for booting purpose. So all the booting related informations will be stored in the boot block or boot sector. Then we have super block, then we have inodes, and we have data blocks. So basically super block contains all the informations about how the file is configured, such as block size, block address range, and mount status. Like it is very much similar, we can say super block is very much similar to MFT in NTFS file systems, because it has also contain the informations like what is the size, block address range, that from which block to which block this particular files is basically stored, and whether it is mounted or not mounted. So these are all information consist in the super block. Then we have inodes and data block. So inode contain the file attributes, like map indicating with where the block of the files are located on the disk. So basically the size of the inode is generally 128 bytes, and data blocks where actual file contents are basically stored. So in this area, actual files, whatever information we are storing, it is there. So inode in position 2 of the table usually point the entry of the root directory file in the file systems. At the forensic point of view, these blocks are quite important, and from their inodes and super block we can get the actual file related mapping informations, and from data blocks we can get that informations. Now in journaling file systems, it is also used in Windows operating system file system in NTFS, and it is used in Linux as well. So these are gives the log of the changes that is being made during this disk writing, and it can be used to reconstruct that may be due to system crash or power failure. So sometimes you can able to see that this particular file can be open in recovery mode. So due to these features, we are able to do that. Now how data can be recovered in Linux file systems. So because in file system, if inode is related, what will be happen? Because there is four major block is there: boot block, then we have super block, then we have inodes, which is pointed basically mapping informations. Suppose in case of at the time of deletions, data inodes is related, so all the mappings will be erased. In that case, how will get the data? So if it is ext3 or ext4, that case we use the data carving techniques. Data carving techniques, what is that? We can learn details in the disk forensics. In data carving techniques, we don't have the informations of the files type available. We provide the header informations to this particular data, and based upon the, if it is matches, we can recover the data from the different location, hidden locations of partial files is there. So we can use the carving techniques. We can recover the data. Details you can learn in the next sessions in this forensics. So what is the data carving techniques? So that I'm not going to discuss more detail over here. We're basically concentrating on file systems, and so I'm just stick over there. Now another file system is now we are using mobile phones or laptops, Apple file system. So this file system standards for iOS and Mac disk drive. So now the updated version is FHS Plus, which is 19, but starting with iOS, Mac OS Sierra, and Apple file system is US standard. So now we are using APFS. So let's see, and it is quite different from the Linux or Windows. So its file system partition is a single container which provides space management and crash protection, and it can be contain multiple volume, which is also known as file system, and each of which contains a directory structure for files and folder. And for example, you can see how storage device of partitions. So the major division of space inside the container. So you can say storage device, where you have GUID partition table, then EFI file system partitions, and we have Apple file system container. In that locations we can get, it has super block, then we have checkpoint area, then we have space manager area, which can manage whenever you file any file you are creating, that space manager will be decide which location this particular file will be stored, and storage for object and files data. So in that area, so if Apple file system container has super block, checkpoints area, and space manager area, and it is for the storage for objects and data files. So whenever analysis point of view, the Apple file system container is quite important, and we are generally learning the structures, how the file is organized. Based upon that, for different operating system, different hard disk, we have to use different kind of tools. One or more tools is required, because using single tools, it is not possible to you will get the required result, because some of the tools are basically work on quite for Windows, some for the Linux, some for the basically Apple system. Single tools is not possible to analyze all the systems. Sometimes it is possible, like advanced tools are there, but more than one tools analysis is required every time to proper get the data, because different tools have different capability. So now we will discuss about Android file systems. So Android is basically, we are using in generally Android phones just for call, SMS, browsing and basics app. But from the development perspective, we should know about the Android internal structure. So Android uses several partitions like boot, system, recovery, data to organize file and folders on the device, just like Windows OS. So in case of Windows OS as well, and also in case of different smartphones, generally we are using Android file systems. So Android file systems, because we are how actually data is organized in that particular OS. So for forensic point of view, if you want to learn how you can get the data, how the data is organized, how data is recovered, what happens when we generally we delete the data, how we can recover the data, what are the possibilities, how we can hide the data, all these things. So for this purpose, we have to understand the structure of the file systems. So like boot, as its name suggests, so there is a 6 partitions and tables like boot, system, recovery, data, cache and miscellaneous. So these are the 6 partitions generally found in any Android device. So these are the partitions. Analyzing, first we will understand what are the information stored in this particular partitions. So maybe some information is available in 6 partition, in some device maybe more. So first we will discuss about the boot partitions of the Android file systems. So device will be not boot without this partition. So whenever this partition will be damaged, or if there is any problems, your device will be not boot. It will be not working properly, because in earlier operating system also, if it is the 0S sectors or boot sectors is damaged, in that case we are unable to boot that systems. So in similar manner, in Android file systems also, if device will be not boot, if this partition is basically damaged, so wiping this partition from recovery should only be done if absolutely required once, and device may not be rebooted before installing the new one. So which can be done installing a ROM, which include a boot partition. So boot partition is quite important to booting a device. Then another partition is system partition. So these partitions contains entire Android OS. So this includes the Android GUI, and all the system application that are pre-installed on the device. So this is basically wiping this partition will remove Android from the device without rendering it and unbootable, and you will be still be able to put the phone into recovery mode or bootloader mode to install a new ROM. So in that case also it is the system partitions. If you are wiping this partition, you will remove Android from the device, but it is not bootable, but still you can put phone for the recovery mode. Then we have another file systems is recovery. This is basically designed for backup. So this recovery partition is considered as alternative boot partition, and that lets the device boot into recovery console performing advanced recovery and maintenance operation on it. So sometimes in Windows also, sometimes we create a recovery partitions. And in case of Android phone also, we have recovery partition. It is really designed for the backup. If there is any alternate, any problems, we can put our device from the recovery mode. We can sometimes run our phone in recovery mode, and we can get to work our device properly. Then we have data. So this partition is also called data partition, and this partition contains the user data like contacts, SMS, settings, and all Android application that we have installed. So Android data partitions, we have this kind of informations, whatever user information, settings, applications, these are all over in this particular partitions. So whenever you are doing factory reset on device, this partition will be wiped out. So your all settings, all contacts, all SMS, everything will be wiped out, and your device will be in the state when you can use for the first time. So this way it was after the last official or custom ROM installation. Sometimes we don't want, if you give phone to someone, you want to, generally we are used to do the factory reset. But what we are thinking that in normal case, all these informations are generally wiped out. But there is some advanced tools is still available. After factory reset also, data can be recovered. So best thing is that if you are sometimes the user replacing their mobile phones, sometimes they get the offers that they can replace, they will get cashback, they can replace their old phones with, because in mobile phones you have a lot of information, lot of data, your personal data is involved. So if you are doing factory reset mode and selling it, it's okay, but what I suggest that you can just encrypt your informations so that if any advanced tool is also used, your information will be not retrieved. Because nowadays, every day in case of mobile forensics, lot of tools, technologies are coming up, advanced options is available, your data might be retrieved. And your in mobile phones, generally we are storing, in case of systems, most of the information, our bank related information, our personal photographs, our videos, everything generally we are storing in our mobile phones. So it is quite crucial to take care of your mobile phones, because it is totally your personal data, and if you are not properly handled, it may be misused by someone else. Then we have another partition is cache, and in this partition where Android store frequently access data, and app components. And wiping the cache doesn't affect your personal data. We simply get rid of existing data there, and which will be automatically revealed as continue using the device. Then we have miscellaneous partitions. So this contains miscellaneous system settings in form of on or off switches. And these settings may include carrier or region ID, USB configurations, and certain hardware settings. And this is the important partition. And if it is corrupted or missing, several of the device features will be not function normally. So this is the brief introduction of the storage device and file systems. If you have any questions, you can ask, because I know this is complete theoretical sessions. And mostly this is a one-way session. Nobody is asking any questions, no discussions, because whatever earlier session we have taken online mode, we have a lot of discussions. And I think everybody, just muted and just what I can say, after the lunch, the session is really some bit of I don't say it's boring. It's maybe some more theoretical sessions. Sometimes lack of concentrations is as well. So if you have any query, any question, you can ask.
Ma'am, this is Madhav Rao. Hello.
Yes, sir.
Ma'am, actually, in storage devices like hard disks and all storage systems, if
Yes.
anything got corrupted, what is the best tools to recover the data?
Sir, if it is corrupted, like first we can use some software tools we can use. If it is first it is accessible to the tool. If it is accessible, then we can do the imaging and then we can recover the data, right? But if it is like first sectors is corrupted, in that case we some hardware tools is required, so that can be corrected. Like for this forensic point of view, if it is there is bad sector, so first we will do the imaging, we able to know which sectors are generally bad sectors. If the number of bad sectors are very large number, in that case data recovery is not possible. So generally we are using forensic tool. There is a FTK, and we have the CDAC tool also, that is forensic tool, cyber check suite, or we can use these two tools are quite efficient. We can work on that and we can get the result. If it is accessible to the tool, we can easily recover the data. Not only your current data, but your deleted data, your overwritten data, all the informations can be recovered. So FTK is basically quite, I think I have used work on both the tool, but FTK is quite advanced than our cyber check suite. So both the tool you can use.
Okay, ma'am. Thank you.
Ma'am, if I just ask regarding the data security, is the data security has to do something with the kind of operating system that we are using? Like people generally say that Mac is more secure as compared to the Microsoft, the operating system, because of the Linux, its development is there in Linux. So do you have to say something about it? Is it something more related to the security with respect to the operating system we are using?
Yes, because Linux is more secure than Windows operating system. So in most of the server, that's why we are using, because it's kernel based and command based systems, and Microsoft Windows has more less secure than Linux. So most of the server we are using Linux operating systems.
All right, thank you.
Anything else you want to discuss, you want to add? Yes, suggestion at your end?
There is one suggestion I would like Ms. to mention, that you can also add
Yes,
the
sir.
Apple operating system.
Yes, sir.
Hello.
Yes, sir.
I'm saying you can also put some more light on the Apple iOS because you have ended
Apple
at the
iOS I have
Android.
already discussed. Apple iOS is basically one of the container that is all the information like there is a space manager, there is a like simply manner, there is a data area. I think you have seen in the slide also. I have already discussed. If you wish, I can show you again. Mm,
I think I missed somewhere.
just a minute. I will show you. Before that, we have discussed what this is what we have. This is basically Apple file systems. So it has a Apple file system container where all the informations related to data like super block. Then we have checkpoint area and a space manager area, which is manage what are the file information will be a storage object for the data area. Like in earlier also, we have seen the data area, actual data is stored and a space manager will be managed at which location the particular file will be stored in Apple's file system as well. So in a storage device, in case of Apple, there is a UID partition, then we have EFI system partition, and Apple file system container contain all the data related informations.
Thank you. Thank you.
Okay, sir. Anything else? If you have any query, you can ask. Any of the operating systems?
Ma'am, this is Madhav here. Is there any technology from coming to the storage like to prevent this ransomware attacks or data modification? Because usually we have faced recently some issue with ransomware. We cannot able
The
to prevent it.
ransomware attack, for this ransomware attack, there is a mechanism, but one thing you can do, you don't put your precious data, some backups should be there. So whenever you are creating any important data, you have to put a backup somewhere else so that if any ransomware attack will be happen, in that case you don't have to put the ransom, you just format your system and you can use and your data is still there, because whatever ransom they're asking for your data only, no?
Yes, ma'am.
Right? Because there is no tool that every ransomware attack will be generally they can stop. There is some prevention measure we can use, because prevention is also better than cure. So some tools is there, some technology is there, but still day by day they are creating new kind of ransomware. So some of the ransomware they can identify, but sometimes it might be possible they don't identify the ransomware and they genuine request they can understand and they can just attack it. Because in case of WannaCry, you can see that millions of computers are affected.
Yes, ma'am.
So there is you have to always keep a backup of your important informations in somewhere else.
Okay, ma'am. Thank you.
Okay, welcome, sir. Anything else, sir?
So now I think we can wind up this session, Prabha.
Yes.
Okay, so let's have a 15-minute break, and after that we'll have a session on disk forensics, where we'll see how we can create the image of the disk or any external devices where you can store the data, and how we can analyze that data. Okay, so let's have a 15-minute break, and then we'll continue the next session. Thank you, Prabha. Thank you so much.
Thank you, Kanti.
Good afternoon. I'm Kanti Singh. So this is our last session. Actually, today in morning session inaugural we got delayed almost for 1 hour. So let's start the session, and we'll actually cover disk forensic tomorrow. Also, we'll have a demonstration of the tool, and I'll request all of you to download one of the tools that is quite useful for the disk forensics. I'll share the link in the WhatsApp group, that is cyberforensics.in. From this, one-time registration is required. Once you register, you have to just log in, and there is one tab, downloads. Okay, so go to the downloads tab, and cyber check suite is the name of the tool that you can download. And tomorrow I'll demonstrate that tool, that if we how we can create the image of for any storage device, external storage device, and how we can analyze that data, okay, for which we have created the image. So I just shared my slide. Let's start with the slides. If you have anyone is having any query, you can ask in between also. So I'm Kanti Singh. I'm working as a principal technical officer in CDAC Noida, and I have worked in digital forensic domain for capacity building project that was funded by the Ministry of Information Technology. And actually, this topic is introduction to disk forensics. Is actually, as in previous session, we have learned that there are different classic categories of digital forensics. Earlier, in now means it was called as computer forensics, but nowadays it is not, that term is not relevant. Okay, nowadays we call it, we use a broader term, that is digital forensics, and this one is basic one, that is disk forensics. Apart from this, we have the next category, that is for live forensics, then network forensic, mobile forensic, and it is not limited to this 4 classic categories, but also, as we have seen in Professor Naveen Chaudhary sir's presentation, it is now actually dark web forensics, IoT forensics, cloud forensics, and vehicle forensics. So database forensics, multimedia forensics, internet forensics. So wherever we are using the digital application, wherever we are using the digital devices where we can store the data, we can share the file, everywhere we actually we have, there will be some intrusion in the data, there will be some hacking, there will be some tampering of the data. So in all those devices we need to perform some forensics so that we can find out the evidences that we can present to the court, right? So today we'll start with disk forensics, because time is actually now 4:25. So we'll try to cover as much as we can in today's session, and later on in tomorrow's session we'll have a demonstration of the tool, hands-on of the tool. If all of you can download that particular tool that I have mentioned, I'll share the link of the tool also. You can download in your systems, and if you have 16 GB, 8 GB pen drives, okay, then you can just create image from yourself also, and whatever that data that is residing in your storage device, you can analyze that data. Okay, you can do parallelly with me also, or later on also you can do, because online sessions will try to make you understand as much as possible. But after the training program also, you all of you have our email IDs. You can contact us anytime. We'll try to help you out. So what are the different topics that I'm going to cover in disk forensic? So I'll start with the basic of means how we can define the disk forensic, what actually includes in disk forensics, how we can collect the data from the disk, what are the different tools we have, how we can analyze the data if we have collected the image, and I will demonstrate the tool also that actually will do tomorrow's in tomorrow's session extensively, because all of you, because that is we want that should be hands-on session. Parallelly, as not all of you, if not possible, then as much as participants can do, we will try to do the hands-on sessions. Okay. So, and the challenges also, as all the speakers has said, that in forensics the challenges are very, means, because who are actually using these tools in India. Actually, capacity building program or this type of training programs are very relevant, because not only this is required for the faculties or researcher community, or people who are actually not from that computer domain but are interested to work in this area, to want to understand this domain, but actually it is field for the law enforcement people, the police who are actually working in the cybercrime cell. They should know that if they reach to the place where actually crime happened at the crime scene, how they should investigate, how they should start their investigation, how they should seize the all the devices that they think that they, all the devices that can actually contain some data that must be relevant for the case, particular case, for particular crime. So, and then if they have collected, if they have seized the devices, okay, then how they can preserve those devices. After that, how they can acquire the data from those devices. And once they have acquired the data, how they can analyze that data. Not only analyze, because at the end of the day, we need to present it to the law court, and they can't understand the language or the tools or your screenshot. You have to write the proper technical documentation that should be admissible to the court. Okay, so all these things we will try to cover in our 5 days session. And for all of you, one more thing, as a FDP coordinator for this program, I would like to just remind all of you that please try to attain the classes, because I have shared the instruction sheet also in the mail, that at least 80% attendance is required. Okay, and second thing is, in your schedule you can see last day we have post test, means we'll take a test based on the session that we'll take in 5 days. Okay, so there will be a few questions, you have to answer those questions, MCQs only, but you have to score at least 60% marks so that you can get the e-certificate. So all of you, I request, please pay attention. Whatever we are sharing with you, whatever information we are sharing with you, we'll try to get the slides from the external expert and share with all of you as soon as possible. But these slides, like from me and previous speaker, she has taken the previous session. These 2 slides today only I will share with all of you. Okay, so we'll share as much as content we can per day, and from my side it is request that please try to understand the thing that if you want to get the e-certificate, you have to score 60% marks, right? So let's start this forensics. This forensics, how we can define the this forensics? Okay, so this forensic is the science like any other science, where we actually focus on extracting forensic information. So what kind of forensic information we can get? We can get digital data, means simply we can put it in another words, file data. Anything, any multimedia, text, audio, video, images, anything, animation, whatever we create in computers or any other digital device, okay, that will reside in the digital device as data only. So we try in this forensic to extract forensic information from digital storage media. Few are mentioned here in the slide, but it is not limited to hard disk, USB devices, CD, DVD, flash drives, or like means so many devices are there. So from each device we can, there are so many different types of tools available. Okay, in India there are we have from CDAC. Cyber check suit is for this forensic that we mostly cover in our training programs. But as my colleague, my friend has, she also shared with all of you, there are other tools also like FTK Imager and FTK Analyzer. This is a proprietary tool. You cannot use, it is not means open source. Proprietary tool is there, FTK Imager and FTK Analyzer. And then autopsy is there, OS forensic is there. But most of the tools are proprietary tools. The CyberCheck suite is also proprietary tool, but it is available for most of the time for 3 months trial. And I think 3 months is, if you are interested, you can learn it, means something. And again, you can just download next time also if the setup expires. Next time, whenever the new setup is uploaded to the website, you can just download the new one and remove the earlier one. So you can use the academic version, right? So what is actually in basic computer architecture? All of us know these things, that in computer there will be a CPU, main memory. Okay, so memory also is nowadays considered as a complete new domain of forensics. It is called as memory forensics because it stores lot of data, and not only that lot of data, means the data which is actually meaningful, right? So in memory we have two type of data, volatile and non-volatile. Volatile data means the data that will reside in your computer till the system is on. Once you will turn off the system, everything will be vanished. In second type of data, that is persistent or non-volatile memory data, the data will be maintained whether system is on or off, means across the shutdowns the data will be maintained, right? All the data files, all the temporary files, registry entries. Okay, because in Windows, most of us are very much familiar with Windows operating system, but there are different types of operating system where we work. Linux is there, iOS is there, Android is there. So different types of operating system, but actually they rely on the registry files, registry entries. Whenever you install any operating system, there will be registry entries related to your machine, related to your number of users that you have created for your machine, all the software that you have installed in your machine. Okay, so all of the information is available actually in your machine itself. But that actually you can get all those data you can get by using the digital forensic tools. We'll try to explore this data, that how you can get the data files, how you can get the registry files, or whatever is available in your pen drive or disk, hard disk drive. Okay, we'll try to explore in tomorrow's session. And then unallocated space. Why we are referring to unallocated space and what it means? In computer, allocated space means the space where we have some data. Okay, all of us know, we have seen that there are different types of file system. Okay, in different operating system, it uses different type of file system where each and every file in your system is actually registered in such a way that you can get the detail, where it is actually stored. The counter is there, you can find out the exact location of your file. So the space where file is allocated is important for us, that we can understand very easily. But why unallocated space? Because unallocated space stores the data which is actually deleted by the user, but the pointer is there in your file system, and if there is no new data that is written in the same space, okay, there is a chance, there is a possibility that you can recover that deleted data. So unallocated space, log files, email. Most of the time, like in CDAC also, we have our official email ID, and we get so many mails, official mails, that we have to save in our systems. So what we do, we configure in Outlook. Okay, so and it stores a heavy amount, means a heavy amount of data. So we can use that emails also. We can get the data that stores the email of the user, so that we can get information that a particular user has communicated to whom. Okay, date wise also communication we can check for analysis purpose. So basically, there is one session in upcoming days for live forensics. Okay, so you can understand here disk forensic. What is disk forensic? Disk name itself tells you. The disk forensic is also known as dead forensics. Like live, it is opposite of live forensics. Disk forensic is also referred as dead forensics. Means when we perform the disk forensic, when computer is off, when you reach to the crime scene, okay, and you find out that there are a lot of computers or laptop are there, but it is not open. Nobody is working on them. It is off already. They are all off. Okay, so what you will do? You will first open the cabinet, identify all the components, and document system configuration, because there are so many different type of system configuration we have nowadays in market. So you have to write down each and everything. In digital forensic, it is not limited to the word digital, because each and everything, as I said, you cannot maintain digitally, because people who are actually reached to the scene of crime, they will be the police officials. Sub-inspector level people are actually they should be assigned this work. So they should actually know that how to handle the scene of crime. They should know how to identify the components, and then once they have identified the component, they should write each and every detail. Okay, they should photograph each and everything. They should disconnect all drives except CD-ROMs drive from the machine. They should label each and everything that they have seized from the scene of crime. And before packaging, before preserving everything from scene of crime, they should ensure that all the drivers are empty. Because this hard disk only will be used to create the images, to acquire the data. Okay. So seizing electronic device, this process where you identify and you just pick up those devices that you think as a police officer, as a person who is assigned the task to work on the scene of crime. Okay, so you have to actually find out, you have to identify the devices. And in India actually, police officials or sub-inspector level police officials, they are not trained that much. So most of the time, FSL, Forensic Science Laboratories resource person, they are actually called for the seize and all. Or what they do, they just seize the things and they do not perform the things that is related to the software. Right? Seize operation is actually related to the software. You can just identify, you can label, you can package, all these things you can do. But before that, you should seize. Why we should seize the things? Because what happens that if you said that, okay, I have collected from the scene of crime 500 GB hard disk. You can write the configuration also. But what is how you can validate that this is the same hard disk that you have recovered from the scene of crime and that is available in your forensic science laboratory? So you need some assurance. You need something that should actually verify that yes, the same hard disk that was recovered from the scene of crime, that was seized from the scene of crime, is actually handled to the FSL people for the analysis purpose, for the seize also, for the data acquisition also, right? So how we can do that, that also we'll cover in the demonstration of the tool. So actually when we seize something, whether it is hard disk, pen drive or any other device, okay, we have to ensure that we have to work on the write protected mode. Okay, we have to use write blockers. There are two types of write blockers available, hardware as well as software write blocker. So we need to use write blockers. Why we need to use write blockers? Because when we want to seize the data, when we want to get the information about the hard disk, means whenever we seize the hard disk, what kind of information we will get? We will get the information about the hard disk related to the hard disk, means the number, the storage capacity, everything that is related to the hard disk, so that we can uniquely identify the hard disk along with the hash value. Right, because as in earlier session you have learned that in hard disk it stores the data and the minimal or the smallest unit to store the data is sectors, and the group of sector is called clusters, and at least few clusters are required to create the file, or at least 4 MB. One cluster is equals to 4 MB. So whenever, most of the time in the standard Windows operating system, when we create any file, the default file size is 4 MB. So the data is there. So the data should be also protected with the hash value. The device should be protected with the hash value. And the report which shows that this is the disk information, this is the data information, that should also be hashed. So 3 hash values should be generated at the time of seizure. Okay. So, and you have to ensure that you are using the write blocker so that there will be no tampering of the data. It should write block. It should block the writing operation by any external application, and then authenticates itself. So two things I will show you how for this we will see how we can seize any device, okay, how we can acquire the data, and how we can analyze the data with the help of the tool. But let's first understand each and every step so that we can just go with the flow when we will use the tool. Then what actually the Caesar wizard will contain? It will show the system configuration. It will divide all the media into blocks. Blocks is nothing but the clusters only, group of clusters. Okay, sometimes in Linux or in different operating system, clusters are referred as the block also. So read the Caesar tool, or read each block and calculates the block hash value. Most of the participants must be aware with this term hash value, because hash is a very important term. We'll see the coming slide. At the when we use the tool, we'll get the hash values, different types of hash values, and actually we'll get a report, Caesar report, okay, which will include all the configuration details of the system and disk. Disk is written here because we are referring that we have seized a disk from the crime scene, not necessarily disk always. If you have collected any other device, you can write down it there. Then information provided by the investigating official. Then disk hash value, or the device that you have collected from the scene of crime. Block hash value, the data that is stored in that particular device. And After that, the hash value for the report, which stores the disk hash value data also and the block hash value data also. And after that, the Caesar tool will copy the details to a physical Caesar memo. Each and everything should be actually not only the digital, but you have to maintain the physical copies also, because if some crime happens, mostly in India, it takes at least 2 to 3 years. Okay, and meanwhile, it is possible that police official or people who are working in the case, there will be a change in the group. So each and everything should be written. Each and every data should be maintained in a physical copy also. So there is a need to copy each and every detail to a physical Caesar memo. Okay, whatever is available through your software, you have to rewrite each and everything in your physical copy also. Then the next thing is, same time from that Caesar tools. Tool means the application only, right? So Caesar application will transfer to all the data, disk value, block hash value, report hash value, all this data to any external storage devices. Here in a slide you can see CD or USB, but in to any storage media. Now, very important thing is, we need to actually in book, if you go through the book for cyber forensic, digital forensic, they always say that at least 2 copies should be maintained, primary and secondary. But as far as practically means, we have seen that they maintain or they should maintain 4 copies. One for suspect, one for the lab, one for the court, and one for the investigating officer. Now, what the document? You just started explaining. If anybody means, if anybody is having any problem with my flow or anything, you can just unmute yourself and say if any means everything is fine. Okay.
Yes, everything is fine.
Yes,
Please go
ma'am.
ahead.
Continue.
Okay. Actually, we have less time now, so I want to means cover things, each and everything. But if I'm going slow or if I'm going fast, you can just correct me then and there, right? So now documentation. As I said, documentation is also required because in digital things, that hard disk you cannot show to the court. That pen drive you cannot show to the court. Whatever you have collected from the tool, you can take the screenshot, shots print out, but that should be actually written. That should be explained, so that anybody who is novice, who don't know the digital forensics, who don't know all the terminologies related to the computers, related to the network, related to the other things, they should also understand. Okay, it should be presentable to the court. So every evidence must be tagged, numbered, tag number to match serial number given in your Caesar memo. Every time you have to match physical copy also with the digital one. Photograph evidences. This is very important. If anybody goes to the scene of crime, whether police official, sub-inspector level, or sometimes FSL resource person, it is mandatory nowadays, not only the photograph, but they should make a video also, because in photographs there are static images, there is a possibility that we can miss something, but in video nowadays they are asked to create the videos for each and everything, that they can see and again each and everything in detail. Okay, so all these are actually evidence. They act as evidence for your case. So photograph, take the videos at original location, and subsequently after tagging. Each and everything you have to tag. Now, crime, let's say crime happened in one state or in any city, and the FSL or in lab or wherever you want to analyze that data is far away. Then packaging and transporting is also very important. So how you can package? For this, we have to use the bubble wrap. Anti-static bubble wraps are actually used for magnetic media devices. Why? Because if you will not use anti-static bubble wrap, okay, all the CD, hard disk, all these electronic devices, actually they are not electronic, they are electromagnetic devices. They actually, if they come if they come into the vicinity of electromagnetic emissions or radio transmission, there is a chance that they may get tampered. Okay, so to protect your seized data, to protect your seized device, you need to use bubble wrap, anti-static bubble wrap, and at the time while you are transporting that device, place the all device here. I'm not talking only about the disk, pen drive, hard disk, or not only DVD, this thing, but computer, monitor, mouse, keyboard, printer, scanner, sometimes notebooks also. They also can act evidence for use, because a few people write their password in their notebook. Sometimes some people they use some papers, small papers, where they write their password and put inside the drawer and somewhere. So anything that you have collected from the scene of crime, package it, okay, and try to protect it while transporting. Place everything securely, okay, because when the transportation happens, means you are traveling from one place to another place, you have to be very careful that your data should be, your devices should be, that when you seize the device, okay, not just identify and pick data, you seize the device, means seize is a application that we can perform through the software. Sorry, hello. Sorry. So I said that there will be 3 hash value you will get. One for the device, one for the data, that is block hash value, and another for the report that stores everything, block data also, and the disk data hash value also. So what is actually the hash value? How I get hash value, and what is the purpose to create the hash value for each and everything? So hashing is the transformation of a string of characters into a usually shorter fixed length value, or simply you can say a string or a key which stores a set of alphanumeric values, okay, that represents the original string. Whenever you create a hash value for your file, it will be a unique hash value. And what is hash value? Hash value is nothing but a set of unique characters, alphanumeric values. And if there is any change in your file, something if you have deleted, if you have added something, okay, and you try to generate the hash value for the same file, you will get the different hash value this time. So what is the purpose of hashing? With the help of hashing, we actually we are creating the unique value for our file. And if there is any tampering, if there is any modification in our file, we'll get the different hash value. And if there is a mismatch, we can say that there is a data tampering. So hashing is very, very important aspect in the forensics. Different hash values implies different contents. If the hash value is different, then the content is also different. Identical hashes suggest identical content. Sometimes what happens, because hashing, how we do hashing? Hashing all is done by the application, by the program, but program is actually written using the algorithm. The algorithm is written as a program, and when that program or set of code executes in your computer, okay, it produces a hash string. But there are different types of hashing algorithm. MD5 is the oldest one, message digest 5, and after that we have different type. Nowadays the latest one is SHA 256, secure hash authentication 256. Earlier one was SHA 128 bit. Okay, so there are different types of hashing algorithm. So based on the hashing algorithm, it is possible that sometimes you will get the same hash value. So whenever you are working on digital forensic tool, always remember that same hash algorithm you have to apply for any file at the time of seize also and at the time of analysis also. If the hashing algorithm is changed, then you will not be able to get the data. So always remember, same hashing algorithm you need to apply. Okay, hash value is nothing but the unique value generated for your file. Okay, that is actually used to verify integrity of evidence. By using the hash value, you can verify the integrity of your digital evidence. If it is not same, it means there is some tampering. Automatically identify known content during the on investigation. It can do that. An example, as you can see, as I told, MD5 SHA2 is given here, but there are so many other. So we'll see how we can apply, how we can generate the hash value. Just I have one example given in this slide, that let's say we are using the MD5 hashing algorithm. We have one file. The name of that file is test.doc file. Okay, and the content is inside that test.doc is hang him not, then comma is there, kill him. Right? Now, with the help of hasher is what? Software application which uses MD5 hashing algorithm. Right? So when we run this on hasher tool, this test.doc file will get this unique hash value. Right? But if the same test.dot, if someone performs some modification, how? Hang him, then just you can alter the space of the comma. Instead of after not, you can just place it after him. Hang him, not kill him. And now try to generate the hash value for this file. There is a small modification only, that you have changed the place of comma. But this time you will get the different hash value. It means you can easily identify that this test.doc is not same as this one. There is some modification. So this thing is actually very useful for the digital evidences. That's why we use the hashing, so that we can verify the integrity of our digital evidences. Now, once you have seized everything, okay, you know that this is the disk, suspect disk, actually not the disk, this is the suspect disk. Okay, and now the second thing will be, you now need to acquire the data from the suspect disk. So how? So the process of acquiring the data is actually called data acquisition. The process of making a bit stream image of the digital evidence. And again, always I'm telling all of you that data acquisition is always done in a trusted, write blocked environment, because if there is some file running in your system which is actually some malware, bad program, having worm or any virus or rootkit, they can try to actually tamper your data. So always use write blockers, either hardware or sometimes in most of the tools nowadays they provide software write blockers. Okay, so software write blocker or hardware write blocker. Then acquisition of evidence is normally done after the process of seizure, because if you have not seized anything, how will you acquire the data? How will you get the data? How will you get the evidence? Because evidence is not the disk. Evidence is actually digital for us. The files that is actually residing in the disk, that is the evidence for us. Okay, so we need to acquire that digital evidence. So first we need to seize the evidence. Then acquisition needs a higher capacity destination than the source one. What it means? That if the suspect device's storage capacity is, let's say, 2 GB, then the destination storage device where you want to create the image, where you want to acquire the digital data from the suspect device, should have storage capacity more than 2 GB. Why? Because we have learned about the file system. Okay, in our storage devices, not it needs to store the data not only for the files but also related to the device. Okay, so if I say that the storage capacity of this pen drive is 4 GB, all 4 GB is not accessible to store the data. Few KBs data will be actually used for the pen drive's information itself. So it is called as the cardinal rule for the digital evidence acquisition, that the original evidence should not be used for any cyber forensic analysis. As I told in previous slide, we cannot use the primary evidence. We need to make copies, at least 2 copies, primary and secondary, because if something happens to the secondary one, we can again use the primary one. But as I have told all of you, we should maintain 4 copies for suspect, lab, court, and for the investigating officer. Now, acquiring evidence from suspect media needs special techniques. Okay, how you can acquire the data? Is there any way? So we'll see how we can acquire the data, and that acquisition technique should be the correct one, the complete one, right? So for this, we actually the software or application which creates the image, they use bit stream imaging, which is the safest technique to acquire digital evidence sources. How it works? How bit stream imaging works? Imaging means it creates image of the data. How it creates? It works bit by bit. It works sector by sector, and sector, all of us know, is the smallest unit to store the data. So it gets data from sector by sector, and when you perform bit stream imaging, it doesn't leave any area of hard disk untouched, whether it is allocated or unallocated. Okay, everything will be covered. Copies location of the data. Okay, preserves drive geometry, also to restore the image into a bootable disk. If in future, if you want to create the bootable disk, then you have to preserve the drive geometry. So by applying the bit stream imaging, you can do. Now, when we create the disk image, what we actually do, we make suspect hard disk or storage media. First thing is read only. How? By using the right blockers, either hardware or software. Second thing, while disk imaging, there should be no alteration of evidence. There should be no data should be changed as it is. Data should be imagined, means everything should be same. There should be no data. There should be no deletion of the data, no introduction of viruses, no data corruption or damages. Sometimes what happens, as I discussed in packaging and transporting also, data should not be damaged also. Sometimes in some hard disk, if part of the hard disk is means damaged, we are not able to get the data. And if the boot sector is damaged, okay, we cannot get, and everything is good, but boot sector is damaged, we won't be able to get the data. So make sure no data corruption is there, no damage is there. And also, once you have created the image, again need to preserve evidence integrity. How? By applying the hashing algorithm, by generating the hash value. Now, one of the participants in the previous session asked question that what are the different tools we can use for the disk forensic, right? So not only for the disk forensics, for any forensic domain, whether it is disk or network or a mobile or any domain you can take. You cannot just use if it is available in open source platform or it is available by any, it is given make available to you by any company. The prerequisite is that it should meet the NIST requirements. And what are these requirements? That the tool shall make a bit stream duplicate or an image of an original disk or partition on fixed or removable media. The tool shall not alter the original disk. Here tools means the software application, forensic application. The tool shall be able to access both ID, SCSI and SATA disk, because there are so many different types of advanced disk available. So each should be actually, you can work with SATA as well as SCI. The tool shall be able to verify the integrity of a disk image file. The tool shall log all the input or output errors. If there is any error, okay, while imaging, while report generation, while seize operation, then each and everything should be logged. The tool shall provide good documentation. At the end of the day, you have to prepare the documentation, you have to generate a report that you can present to the court of law, so that, and your evidence should be admissible enough. Okay, so it shall provide good documentation for you. So if the tool meets the NIST requirements, then only you can use that tool. Now, if you have acquired the data also, you have seized the device, okay, you have verified the integrity of the device, hash value for the disk also, for the data also, for the report also, then you have actually acquired the data from the disk using some seizure tool. Now, what is actually the next task or the next step in forensic? That is analysis. Now you need to analyze what data you have in your image. Okay, and then you have to correlate each and every file. Okay, there are different ways available in different tools through which you can correlate the data. You can find the relationship between the data, right? So basically the process through which the investigator or investigating official use to discover information valuable to an investigation is called forensic analysis. And What is the purpose of forensic analysis? Because we want to get the relevant data for case, okay, and we want to extract that data. We want to get that particular file, what is stored in that file. So how we can perform the forensic analysis? There are two ways, basically two ways. First one is referred as physical analysis and second one is logical analysis. In case of physical analysis, what we do? In physical analysis, it consists of string searches. You can search string because in file there will be text, okay. So you can search the string. If there is any match, it will show, and then you can get the file detail and data extraction across the entire image from normal files to inaccessible portion of the media. Inaccessible portion of the media means unallocated space also, right? Swap space also, slack space also. We'll see yes, tomorrow's session all these things when we'll discover the tool, when we'll have demonstration of the tool, that there are different types of space available in the devices. Slack space, swap space, then unallocated space where we can get actually the relevant data for our case. And then logical analysis. What we mean by the logical analysis? Logical analysis means analyzing the files on the partitions by pursuing the file system in its native format. We have file system for each and every operating system. We know how it works because operating system is actually a combination of hardware and software, okay, and in between there is a firmware. And there are different management tasks given to the different programs: disk management, file management, memory management, okay. So file management will be utilized in case of logical analysis. We will see how. Now, when I say that you can perform the search, what different kind of search for the analysis you can perform as an investigating official. The investigator may analyze the data with 4 major processes. You can search for a keyword because you have all the information related to the case. You have physical seizure memo. You have chain of custody. Chain of custody is one of the very important document, physical document that is maintained by the law enforcement agencies, okay, who are involved in that particular case. They maintain each and everything related to the victim, related to the suspect. Each and everything is documented there. Who is working on that particular case? So each and everything will be there. So based on the case, based on the information you have, you can just create the number of keywords and you can try to find out, you can try to search that particular keyword with the help of the tool. Then you can search the picture also. If you have seized a pen drive which stores 32 GB of the data or 64 GB of the data, there is a chance that you can find few images which will be very helpful for your case. So you can search pictures also, you can search all the images, okay. Sometimes images are also the key for the case. And then file search, you can try to find out different types of files. As in previous session we have learned about anti-forensics. Okay, there will be file, but is it a normal file or is it any anti-forensic file? A file that is protected to stop the forensic analysis with help of anti-forensic mechanisms like password protected file, steganographed file, deleted file. Okay, so there are different ways, encrypted file. So there are different ways to perform the anti-forensics. Tomorrow we have session on anti-forensics. So there are a number of ways. Okay, there are a number of types of files you will get. So you can search the files, and based on the file you can also identify, okay, this file is not normal one. So I can get, there is a chance that some very crucial data I'll find here. Then timeline analysis. What we mean by the timeline analysis? We can analyze the data based on the timeline. Means we can analyze the data that if this file was created from this to this date, we can search for the data based on the particular timeline. Okay. So I think for today's session, shall I continue or from tomorrow onwards we'll continue? Anybody can just unmute and tell me. It is already 5:20 and I can see only 69 participants are online. So just
if you want, you can continue, ma'am. If you want, you can continue. We are listening to you. It's very interesting. And it is very practical oriented, which is actually required afterwards. If you wish, you can continue.
Only 6%. I'll drop a message in WhatsApp group also that actually today's session got delayed because of Naukral. Otherwise, okay, let's continue for 10 more minutes, right? Is it okay?
Yeah. Thank you.
Okay. So timeline analysis is also very important way to find out the data. Let's say the crime happened on 1st of August. So most relevant data that you can get means from the system or from the hard disk or from any device that you have recovered from the scene of crime is actually the file that created in June or July. So if you can find out, there will be if 500 GB storage capacity or 1 TB storage capacity hard disk if you have seized, okay, and if you can get the data within a given time frame and that all the files created from this to this with the help of the tool, you can think how much helpful it will be for you from forensic analysis perspective. So all these are possible through the tools. Okay, that's why, but as I said, one of the tools we are using for tomorrow's session is Cyber Chip Suite. We'll cover that tool. FTK is also there, but as I said, FTK analyzer, there are two parts in FTK. FTK Imager and FTK Analyzer. FTK Imager is free, but not the latest version. Very old version is free. Okay, no use. Means you can use that to just get the overview how FTK interface looks like, what are the different functionalities it can do. But the latest one is very different from the open source that is available on the internet or the surface web. Not in the deep web, surface web. Whenever you search something in Google that is present, that is actually not the latest one, and it cost from 2020 the cost was of FTK analyzer was almost 7 lakh. So it is a little bit but costly, and there is OS forensics is also there through which you can do. Autopsy is also there. Few open source tools are also there, but as I said, one tool is not sufficient enough. Most of the forensic experts in the FSL Forensic Science Laboratory, they don't rely on a single tool. They actually work in case of the mobile phone. Means it is impossible to work in a single tool. So in this also in other domains of forensic also, we cannot rely on a single tool. We have to use combination of the tools so that we can get the most relevant data related to the case. So timeline analysis is very important. I will show in tomorrow's session how you can perform the timeline analysis. Now, probing the system, where you will probe as an investigating, as a forensic expert. You are analyzing the data. You are working as the forensic expert. Forensic analysis is your job. So where you need to probe, where you need to search for the important data, for the crucial data, sensitive data. So slack areas, unallocated areas. Slack areas means sometimes what happens when we store any file. Okay, the as I said, when in Windows operating system, when we create a file, the total file size is 4 MB by default if we do not change the settings. Okay, but the content, we write something and the actual file size is not 4 MB, it stores some KB of the data, but the storage allocated in operating system by the file system is actually 4 MB, and the utilized space is only few KBs. And what about the rest of the MB's space? That space is actually slack area. And how you can use that slack space? Because what happens again and again, there is some rewriting of the data. So there is a chance that something you can get from the slack area. You can get some data from the unallocated area, where data is deleted, pointer is there, because the same space, no new file has been in the same space in your hard disk or in your digital device, no new file has been written. Now, lost cluster or blocks. Sometimes in file system, few clusters, there is no information about the few cluster, lost cluster. So that data also can be useful. And all of us know user created files, because we know that these are the most crucial data for us. User is creating few files, not means without any use. Why you will create any file? There must be some purpose to create file in your system. So user created files, user protected file. If there is a file which is protected by the user, it means which is password protected, which is having the encrypted data, it means it needs to check. It needs to be checked. Okay. Then computer created file. Now what we mean by the computer created file? All of you must know there are some files like page file.sys. Okay. Some files that swap file related to the memory, related to the processes that is running in your machine, in your operating system. Okay. The software that is installed in your machine, the users which are actually given the access control to your machine. The computer created file, the file that are maintained and created by the operating system, this can actually give very relevant information for us. So now I wind up my session, and from tomorrow we'll continue and I'll demonstrate the tool also. All of you, please check your WhatsApp group. I'll share the link from which you can download if you are interested. If anybody is interested, you can just download the tool cyberforensics.in. Let me just write the name of the link. Okay. So it's again cyber forensics. This is the URL. Okay, from this URL you can just register yourself. Okay, and you can download the tool cyberforensics.in. You need to register. One-time registration is required. And then you have to go on the go to the tab, download cyber check suite. This tool we can use for this imaging.
Hello.
Yes. Yes, sir.
Hello.
Is it visible?
No, madam, I can't.
Okay.
Just
Okay.
make the font size bigger. Make the font size like 60 or 72.
Okay.
It will be
Okay.
visible.
Okay.
Thank you. It's visible now.
So this is the URL cyberforensics.in. One-time registration is required, and then after the registration, you will log in with your credentials, and after login, go to the Downloads tab. Here, you can see there is one tool, CyberCheck Suite. This tool we will use for the disk forensics, right, for imaging and analysis purpose. And after the analysis, with the same tool, will generate the report also. So I guess for today, it is today we have started from 10 o'clock morning, and it is now 5:25. So from tomorrow we'll have 3 sessions, right? So
Hello.
yes, yes, sir.
Madam, will you please share the presentation in WhatsApp group?
Yes, I shared previous presentation given by my colleague, my friend, and this one.
Because
For other two
4:30,
presentations,
because after 4:30, madam, I am not able to show any kind of presentation by you. Only I can hear your voice.
all of you have seen all the slides.
Yes, yes, we have seen.
He might have some network issue. That's why he could
Yes,
not able to
yes,
speak.
you might have facing some network issues, I guess, because means everybody is saying that they have seen all the slides. Anyways, I'll share the slides with all of you through WhatsApp group also, and I'll mail also. So
Tomorrow, what is the time?
thank you, all of you, and we'll meet tomorrow again sharp at 9:30, so we can start our session 9 sharp at 9:30, and we can continue. Thank you, all of you. Thank you so much.
Thank you so much.
Thank you, ma'am.
Thank you, ma'am.